So in section 9.1 we talked about the solution to a system of equations was the point where the two lines intersected, and that we could find that solution by graphing. However, graphing is not always going to be the easiest thing to do. It can actually sometimes be the most time-consuming thing to do, even though it best represents the final answer. But in this case, with solving with elimination, we're going to look at a way to find the solution by hand without graphing. So if I look at this system, x minus y equals 2, and x plus y also equals 2. We could do this by graphing, but what I would say I would notice, if you were to combine these two systems together, negative y and positive y would cancel each other out. So what I'm going to think about doing is combining the top line with the line below it. So if I combined x with x, that would be 2x. Negative y and positive y would cancel out. 2 and 2 makes 4. So 2x equals 4. And if I divide by 2, that tells me that x equals 2. That is the x coordinate of the solution. X is 2. Now I can take that and plug it in to either one of these to find y. So let's say we pick the top equation, x minus y equals 2. If I plug 2 in for x, I'd have 2 minus y equals 2. And if I solve that for y, I would say, okay, let's subtract 2 over. That gives me negative y equals 0. And so I could divide both sides by negative 1, and that tells me y equals 0. So the solution to this system of equations is 2, 0. Alright, so let's look at one that's a little bit more difficult. Here we've got 5x plus y equals negative 1, and x minus 3y equals negative 13. Now if you notice right now, nothing would cancel. If I combined 5x with 1x or just x, that would give me 6x. And positive y with negative 3y, that would give me negative 2y. So right now, elimination's not going to work. But we know from algebra, you can do anything to an equation as long as you do it to both sides. So here's what we're going to do. We're actually going to multiply this top line by 3. Everything by 3. And you're probably thinking, well, why am I doing that? What will happen is instead of having just a plus y, I'm going to have a 3y. So let's multiply through and see what we get. 15x plus 3y equals negative 3. You have to multiply everything through. Let's keep our original second equation. X minus 3y equals negative 13. Now we can combine those two lines. 15x and 1x makes 16x. Negative 3 and negative 13 is negative 16. I don't have any y's left because positive 3 and negative 3 would cancel each other out. So let's divide by 16 now, and we get x equals negative 1. Now I can take that value of x and plug it back into either one of these to find y. So since this bottom one just has x, maybe we'll plug it in there. So if I plug in negative 1 for x, I would get negative 1 minus 3y equals negative 13. Solving for y now, we add 1. Negative 3y equals negative 12. And divide by negative 3. Y equals positive 4. So I have the points now. X is negative 1 and y is positive 4. That is the point where those two lines would intersect. That is what we mean by the solution. Okay, let's try another one. 7x minus 4y equals 4. 5x plus 4y equals 8. This one's perfect right now because negative 4y and positive 4y should cancel out. So let's see. 7x minus 4y equals 4. And we're going to combine that with 5x plus 4y equals 8. So negative 4 and positive 4 would cancel out. So 7 plus 5 is 12x. 4 and 8 makes 12. Dividing both sides by 12, we get x equals 1. We can now take that 1 and plug it into either one of our original equations. So let's say we pick the first one. Now we'd have 7 times 1 minus 4y equals 4. 7 minus 4y equals 4. When we do 7 times 1, so we subtract 7 over. Negative 4y equals negative 3. Dividing both sides by negative 4, y equals. Now you'll notice 4 doesn't perfectly go into 3, but we can simplify this thing. This will just be positive 3 over 4 because you have a negative divided by a negative. So here our solution is 1 comma 3 over 4. Okay, here we're going to have a little bit more work to do. We've got negative 5x plus 4y equals negative 31. 13x minus 6y equals 85. And I want to get something to cancel. Here we're actually going to have to multiply both the top and the bottom to make them look similar. So what I would notice is it's going to be easier to make the y's look alike. The reason is I can easily turn both of those y's into 12 y's, with the top one being positive and the bottom one being negative. So I'm going to multiply the top by positive 3, and I'm going to multiply the bottom by 2. Okay, the reason, if I multiply the top by 3, that's going to give me negative 15x plus 12y equals negative 93, multiplying everything through. Multiplying the bottom by 2, 26x minus 12y equals 170. The positive 12y and the minus 12y, that's what I was really looking for, because now those things will cancel. 15x and 26x makes positive 11x. Negative 93 and 170, if you added those two together, would be 77. We divide by 11. X equals 7. So now if we know x equals 7, we can use either one of these equations to find y. Let's pick the top one. Negative 5 times 7 plus 4y equals negative 31. So that'd be negative 35 plus 4y equals negative 31. Adding 35 over. 4y equals 4. If we divide by 4, y is 1. So the solution to this equation, system of equations, is 7 comma 1. Alright, one more time. So if I had this one, 2x minus 5y equals 4, and negative 8x plus 20y equals negative 20. Well, what I would actually try and do here is maybe cancel the x's out, because if I multiply the top line by 4, that's going to give me a positive 8x to cancel with that negative 8x. So I'm going to have, multiplying by 4, 8x minus 20y equals 16. the bottom line would be negative 8x plus 20y equals negative 20. If we combine those lines, well, negative 8x would cancel the 8x, but negative 20 and positive 20y, those would also cancel. And what you would get is a 0 on the left side. Everything would be canceled. 16 and negative 20 makes negative 4. Well, this is actually a unique situation. 0 does not equal negative 4. This system will actually be two lines that never intersect. They are actually parallel lines, and we call this system inconsistent. If you cannot find an answer to the system of equations, if you get 0 equals some number that is not 0, there is no solution to this system of equations.